The real bottleneck isn't model size. It's how fast you metabolize what's shifting. Welcome back to AI on AI Today. We're unpacking participant-aware access control for enterprise LLMs, from fine-tuning to RAG and agents. Buckle up. It's where security, utility, and org charts collide.
I'm coming from a security architecture lens. Short version, probabilistic guardrails are like umbrellas in a hurricane. You feel safer, you still get soaked.
From the modeling side, fine-tuning bakes secrets into weights, and RAG can retrieve them. Together, they're great for quality and risky for multi-user environments.
I've shipped assistance. The failure mode is subtle leakage, not just verbatim quotes. Think paraphrases, hints, or steganography, hidden in plain sight.
Timely backdrop. Major platforms just launched enterprise tuning features and new agent modes, while red teams surfaced fresh indirect prompt injection benchmarks this summer.
The core risk, model access doesn't equal data access, but fine-tuning collapses that boundary. One user's weights can reveal another team's policy.
Add RAG and an adversarial sender can shape retrieval. Drafting a reply to them may accidentally pull restricted docs into context.
Classic example, attacker hides fetch revenue in white-on-white text. Model maps the number to a date, suggesting May 7 instead of saying the number.
Humans rarely spot that. Reviewers approve the draft. It's like smuggling a note inside a handshake.
We tried input sanitization, output filters, even task drift monitors. Helpful but probabilistic. As the saying goes, hope is not a security strategy.
Differential privacy helps per record leakage, but group secrets matter in enterprises. Cranking noise high enough torpedoes utility for legitimate users.
DLP and pattern matchers can't tell if Bob's authorized to learn what the model inferred. They see strings, not permissions.
So what's the deterministic alternative?
Enforce this rule rigorously. Any content used in training, retrieval, or generation must be authorized for all active participants in the interaction.
For fine-tuning, that means granting model access only to users who can access every training document. No exceptions, no probabilistic hedging.
Represent ACLs as a bipartite graph, documents on one side, entities on the other. Secure models correspond to bycliques. Everyone in the entity set can read every document.
Finding the maximum by clique is NP hard, so we use maximal by clique heuristics seeded by common ACLs. It balances entity coverage and document coverage.
Building on that, utility equals coverage. The heuristic effectively maximizes the product of users and documents, subject to access constraints.
Business-wise, per-user models don't scale. Enterprise-wide models miss private knowledge. Bycliques give shareable model slices with auditable scope.
Let's revisit the email assistant pipeline. Where do checks live?
At retrieval, intersect recipients, ACLs with the requesters. If a candidate document isn't readable by everyone involved, exclude it or escalate for explicit consent.
And if no fine-tuned model fits all participants, fall back to a general model. Don't let weights become a side channel.
Input checks like spotlighting help label untrusted text, but they're advisory. Attackers evolve, permissions don't argue.
Output filters and taint tracking catch obvious leaks, not covert encodings. Meeting on the 7th looks harmless to a classifier.
Architectural isolation that freezes control flow is strong, yet steganography still slips through if retrieval pulled unauthorized facts to begin with.
Recent evaluations on indirect injection show transfer across models and prompts. Defense in depth is necessary, but access control is the non-negotiable layer.
I'll push back slightly. Humans in the loop should help, right? Reality check, rushed approvals, missing coded leaks.
Exactly, and here's the contrarian bit. Fully agentic systems can be safer than draft review ones if deterministic ACL enforcement blocks risky context up front.
Nice twist. How about real-world use cases beyond email?
Collaborative docs. Assistants rewrite shared content. Validate every supporting retrieval against all collaborators' permissions before invoking the model.
Customer support bots spanning multiple product lines. Restrict retrieval to the intersection of the requester's tier and the ticket's audience.
Healthcare scribe pulling prior notes. If the recipient lacks consent for a dataset, the assistant shouldn't even embed those notes, let alone summarize them.
Dev Assistant's 2 internal repos with mixed ACLs. Treat code snippets like documents in the graph.
What about changing permissions over time?
Make model selection dynamic. Bind a session to a by-click at request time, not deployment, and invalidate caches when ACLs change.
Logs matter store why each document was eligible, because all participants had read writes, so audits aren't, archaeology.
Heuristic identity first, content second, or good inputs, good outputs becomes good identities, good context.
Analogy time. Guardrails are speed bumps. ACL enforcement is a locked gate with a guest list. Also know you can't bribe the bouncer.
Quick humor if your policy is don't leak, but your retrieval ignores recipients. That's like wearing a seatbelt around your knees.
Any notable, recent developments listeners should track?
Enterprise tuning products now expose participant-aware model scoping, and new benchmarks for indirect injection are out, plus agent frameworks adding masked re-execution.
Expect regulators to ask for attestations, prove that every token in context was eligible for every recipient. Show me the intersection, not just the policy doc.
Implementation checklist. Inventory ACLs. Build the bipartite graph. Enumerate maximal by-clicks. Set thresholds. Wire retrieval to enforce intersections. And test with red team steganography.
Measure 2 KPIs, leakage attempts blocked deterministically, and task success for authorized cohorts. If both look good, you've got product market security.
That's our time. Deterministic, participant-aware access control as the backbone of safe, useful enterprise AI. Thanks all, and see you next episode. Stay with us for a concise summary of the highlights.
Narrated by the AI voice of Shri. The theme is how to stop sensitive data from leaking in enterprise artificial intelligence systems that serve many users. The central claim is that only strict, deterministic, participant-aware access control can reliably prevent leaks. Fine-tuning means continuing to train a pre-trained model on organization-specific data to improve performance. Retrieval augmented generation means fetching relevant documents at query time and adding them to the model's prompt. Access control lists are the permissions that say which users or groups may read each document. Experts warn that fine-tuning on internal data can expose confidential information to users who were never allowed to see the training data. They show that language models can leak training information through memorization or through paraphrased generalization. They also find that retrieval augmented generation can pull restricted documents into the prompt if permissions are not checked for everyone involved. A cross-prompt injection attack means an attacker hides instructions inside content that the system later processes as guidance. One example uses an email assistant that drafts replies using the sender's message and the recipient's mailbox. An attacker sends a normal-looking email that secretly tells the assistant to look up a private revenue number and encode it as a meeting date. The assistant retrieves the confidential figure and outputs a seemingly harmless date that the attacker can decode. This attack can succeed even when a human reviews the draft because the leak is steganographic and not obvious. Existing input checks attempt to sanitize or label untrusted content, but miss many cleverly hidden instructions. Existing output filters scan for sensitive information, but struggle with covert encodings that look benign. System-level isolation can freeze control flow, yet it still fails when the prompt already contains hidden goals. Training-level defenses, like regularization and differential privacy, reduce leakage only probabilistically and often hurt utility for authorized users. Data scrubbing and deduplication help with exact memorization, but do not stop broader policy or strategy leaks. The proposed principle is simple and strict. Any content used for training, retrieval, or generation must be authorized for every user who will receive the output. For fine-tuning, a user may access a fine-tuned model only if that user is allowed to read every document used for training. A bipartite graph represents documents on one side and entities on the other, with edges for allowed access. A bi-clique means every chosen user can access every chosen document, which guarantees safe training and model sharing. Finding the single largest bi-clique is hard, so a practical heuristic expands common permission sets into large maximal bi-cliques. This approach balances document coverage with how many users can share the model, reducing operational costs while staying secure. The method has been deployed in a tuning product for enterprise customers who train models on their own data. During inference, the system must check permissions for all active participants before retrieving or generating with any content. If any participant lacks permission, the system must exclude that material or obtain explicit consent from the authorized user. In multi-recipient emails or shared documents, the system verifies permissions for everyone who will read the output. If no fine-tuned model is safe for all participants, the system falls back to a general-purpose model and restricted context. Open challenges include dynamic permissions, misconfigured permissions, covert leakage through steganography, and the cost of managing many models. Future work explores weighting important users or documents, auditing across multiple models, and better tools to detect permission errors. This matters because deterministic access control can provide clear guarantees, enabling enterprises to safely adopt artificial intelligence at scale. Great insights spread fastest through trusted networks. Share this with a practitioner or strategist you respect.